Welcome to the viewers. I discuss today these few interesting questions that's absolutely very helpful in examination purpose. Let's watch these questions. If Z be the ring of integers, then Z3 is. What is Z3 actually? Is Z3 by 3Z is a field? Simply Z3 is a field. Z3, that's a Z, is not a field. Both A and B is true. Actually, if we consider all of this result, then it is obvious Z is not a field and this is not related with this. So, obviously, it is not correct and not related with this area. So, this is cross. And now, next consideration, Z by 3Z. What actually is? If we consider the ring of a theorem, that's a problem type, ring of integers of all prime ideals are maximum, and if we find it and that P is a prime ideal and Z is a ring of integers, then obviously this prime P exists and we generate this ideal P, and that is we know this P ideal that's generated as Pz in these areas. And now this ideal is generated, and here we consider 3 is a prime number. So here obviously this 3 that's generated 3z in these areas, and we also consider this kind of result, that is z by pz. Here p is prime number, so z by 3z, that's absolutely isomorphic to zp, that is z of 3. And then where this zp, that is z3, is ring of residue classes of modulo 3, this result. So it's clear this is isomorphic and these are the same result. So this is this zp, that is z3, is field, and here this result and this result are same, this isomorphic, so both A and B is true. So obviously number 4 option is correct. Hello viewers, now I discuss which of the following is, that's the following polynomials are primitive polynomials. Now how categorize the primitive polynomial? At first we are going to the definitions. We have to calculate primitive polynomial, that is a CF. What CF is? CF is nothing but the GCD of all these function coefficients, like this a0, a1, a2 up to an, in this way. So here if we calculating this result, that's calculating this GCD of all this polynomial, at first we are doing to this 3, 6, 9 minus 9, 12 minus 3, and 3 is the common factor, and clearly GCD is 3, so it is not 1. If GCD is 1, we declare it as primitive, so it is not. Second option, 1, 1, 2, 3, obviously it's 1. First option, 3, 4, 6, 5, it's also 1. So all this result, this and this are true, so this is true. And now for the next, if R is a ring with unit elements 1 and 5 and is a homomorphism for R on to R dash, then the unit element of R dash is 2, 5, 1, 5a and none of the above. At first we have to solve this result. If we consider like this, phi is homomorphism from R to R dash, and R dash is the homomorphic image of R. If 1 is unit, this unit element, if we consider of R, then obviously phi of 1 is belonging to R dash, it's clear. And let us consider the element choosing, A belongs to R dash, then obviously A dash is R dash, then A dash is phi of A. Some element, if some element A belongs to R, and then phi of 1 A dash, and phi of 1 A dash is phi of A, and the homomorphic property, that is phi of 1 into A, and obviously it is phi of A, and phi of A means A dash. And on the other way, if we take, that's A dash into phi of 1, that is phi of A into phi of 1, that is phi of A dot 1, that is phi of A is A dash. So from this two end we can say phi 1 is unit element, and we already conclude that unit element of this is called the unit element, and unit element of obviously R dash. So we are choosing this option. 2 is not possible. Obviously phi A, it is also not possible. None is not possible. Only option is phi 1. So unit element is phi 1. Now we end our discussions today. If you like this video, like it, share it, and always subscribe the channel, and to get all the notification and latest update of my videos. Thank you.